everyone. In this video, I'll show you how to use Triton, the powerful open source language and compiler for writing high quality and efficient GPU code, especially for ML and AI tasks. So for background or as a brief intro, Triton is developed by OpenAI, which is the same company that makes GPT-4 or 5 if you have used one, or more commonly known as ChatGPT. And they have designed this programming language to make it very accessible for researchers, students, and beginners, so that it is more easy to use. So Python language has become a forefront for ML and AI tasks, especially because of its easier syntax, more community support, and you have more resources for documentation so that it is easy to follow and write new kernels or even APIs. So in this video, I'll be using CUDA 12.8 on RTX 4070 Super. So if you have Blackwell, you can even use 12.9 as well, or even 30 if you have the latest nvidia drivers that was released this month, that is on August, both on game ready drivers as well as studio drivers. So why will we use Triton? So Triton lets you write code that runs fast and efficient on GPUs, often matching or besting the handwritten CUDA programs. It's perfect for tasks like deep learning, scientific computing, and custom operations in PyTorch. So you can mix and match PyTorch, your PyTorch audio, or removing background noise and all those things what you have already done if you are coming from CUDA or PyTorch. So I'll keep the video very simple. So why learn Triton? First point is because of its Python-like syntax, which allows you to easily grasp the concept. So automatic parallelization and optimization, so you don't have to hand code the code so that it runs specifically on each hardware to its maximum efficiency or performance. So it has direct integration with PyTorch. This is open source and community developed. So let's take a look at a simple example. So I'm using Windows for Triton. So it is a separate package. So it's a forked forked package with added support for Windows. So if you're on Linux, you can directly use the package. So for the packaging, I've used UV or pipx. So you can use either of the one to set up your environment. I've defined everything within the PyProject terminal. So it is running on Python 3.12 or later. So 3.13 you will miss some packages, so that's the reason I went with 3.12. So it is widely available and it has security fixes currently. So yeah, so make sure that you have added the index. So in case if you're coming using UV or Pixi for the first time, make sure you use this index as a default. I've added everything as which is as per the requirements. So even I've added few readme things how to use UV. So this is a mermaid diagram. So if you want my mermaid support, just install Markdown Preview Mermaid. So you'll see I've written a brief description using GPT 4.1 and added some fixes to the diagram as well. So in case, so feel free to add a PR in case if there's any mistakes, or just point out it in the comments. So I'll make corrections and push the updated code. So let's start. So this is a test script to see if everything works as expected. You don't require Torch if you are just programming with Triton. So this is, since it's a benchmark of sort where you compare Triton and a Torch on running on the same hardware. So that's the reason. So for Python coders, you will see that you are familiar with the decorator like structure. So this is a decorator that lets Triton know that this is a GPU kernel. So you'll have some arguments. So it can be keyword arguments or any arguments, arbitrary arguments as well. So since it is similar to a vector addition, so there will be X pointer, Y pointer, the output pointer, number of elements, block size. So block size will be, in this example, it is set to 1024, or it will set it to a default one based on your hardware. So before execution, so always set the program ID, the initial thread, to 0. You'll see that most of this code is similar for the next vector addition script that I'll be running. So this is a test script to see that if it is working as expected once you initially install the library. So once you after installing, so you'll see that just run it. So you'll see that CUDA 0. So this means it's the first CUDA GPU. So if you have multiple GPU, that is if you're running it on a rack cloud instance where you have multiple GPUs, you will see CUDA 0 and CUDA 1. CUDA 1. So that it can differentiate between multiple devices. So now let's yeah, there is a fundamental difference between CUDA and Python. So if you see, if you have worked with CUDA in the past with the C or C++ or Python, here it is a number-based example. So like I said, this signifies that it is a GPU kernel. It is similar to your kernel keyword in OpenCL or CUDA. So you write your function, and if it is CUDA, so you'll have something called thread. You should initialize thread ID and block ID for every kernel, so that it can send the instructions block and thread wise. So if you don't initialize, it won't work. So based on the CUDA programming guide, you'll see that there will be always, this is a common code to initialize and send or manipulate your data or process your data with the threads and blocks. So you'll see that you'll have to give a pass an array of grid. So this is another concept wherein CUDA requires that it needs to be a valid grid or SF. So you can this might seem very complex to you. So if you are new to CUDA, so there is something called grid and block as well. So let's switch to Triton. So in Triton, everything is a block operation. and there is you only have to give the program ID. It is similar to the thread ID. So instead of giving blocks, since it is everything is executed as a block construct, so you just have to pass PID, the first thread blocks, and the range of blocks. Then you pass it as a single array. You don't have a two-dimensional array here wherein you have grid and block, but it will be a single. There is no separate thread blocks. I think it is somewhat a different concept. So if you are if you want some background on CUDA, or if you are a Python newbie, just let me know. I'll just add some Jupyter notebook scripts, which I often use for studying the concepts or the definitions, or memorizing the concepts with some examples. So I can add that in the same repo under source folder if you want. So currently everything is in the root folder. So if you, in case if you want that, just let me know in the comments. So I'll add it. So this is the scripts what I've copied from the tutorials. So this is the very first script. It's the exact copy. So like I said, so this is this signifies the start of your GPU kernel. So the device initialization, it's just to get the active torch device. That is, if you have installed a torch and if you want to get which device it is executing on. So that's this is the basic script for that. Now it is, if you see that it is similar to the earlier code what I've explained. So I've added the similar comments. I didn't modify anything. So what it does is it's a vector additions of points x, y, having multiple block sizes. So make sure you, the block size is an even number and it's not an odd number. So initialize, you can so if you have a bigger GPU or a bigger memory, you can change the block size as well. So this is a default testing framework or an API provided by Triton. So this is a benchmark API. So in the benchmark API, so these are all the arguments. You can actually skip self if you are initializing it in this function. So first it will be the name of the sizes, that is the x direction sizes. If you see when I execute it, it will be in the range of 10 to the power x values. So x log. So this will set the x-axis to be logarithmic scaling. Next you have line values that will signify. So we have two kernels here. One runs in Triton and another one runs in Torch. So if you see that this is the PyTorch version. And you can even change this colors as well. given the labels. So labels is set to 3 GB per second performance of the memory bandwidth. You can use your custom plot names, and if there is additional arguments for your custom function or GPU kernel, you can just pass it. So this is a function wherein it's a benchmark function where you, based on the different sizes and the provider, it will return a result, which in turn be used in the performance report. I'll just run it. So if you are on very new GPUs, you will not see very heavy load. The heavy load, what you're seeing is due to nvidia broadcast that is running in the background to remove any noise and other keyboard typing. So as you can see, you get a plot that is this is matplotlib. You can even zoom to see. So the blue one is Triton performance. The green one is torch. So this is due to the things what I've written in line values and names. So this is where the labels or the legends are set. This is called a legend. And if you are very new to plotting, or you can even save the figure. So as you can see, Triton has near identical performance. I think usually the graph will be somewhat higher because there is a heavy GPU usage. That's the reason you'll see a slight dip here. So once I close the things, you'll see the results in your terminal. So this is due to print data true, where you the setting would have passed in benchmark.run. You can even save it if you are running with multiple GPUs in different computers and you want to save the results. You can add save path. So this is the default. You can see if there are different supported arguments. So you can even return it as a data frame for pandas. So it has a panda dependency as well. So I'll put it in results. I'll run it one more time so that you can see the results folder being populated. So yeah, so once you close the plot, the results will be added. Let me go to File Explorer. I run it once again. For some reason it is the PNG is blank, but yeah, the performance is actually same. So there is some, this should be the actual figure. So let me check, and if there's any updated code that can fix it, I'll just push the change. For now, I think this will be the end of the video. So if you have any doubts, just feel free to reach me via the GitHub repo, what I'm linking in the description. So you'll see all these links in the description. I'll add everything. So if you want more programming intros and other stuff, so just let me know in the comments. So thanks for watching. Bye.